Okay, so another thing we need to know is the Laplace transform of f prime of t. And you'll see how that works in a minute, because we're going to apply it to this equation, which would be very simply done. There's something else we've got to know before we can put a y in here, okay? We're going to solve this one just to get the flavor of how this is going to help and what's really going on, okay? So, you got the Laplace transform of f prime of t is this, okay? There are two ways you could set up the integration by parts. You could let u equal f prime of t, so the du is e to the negative st dt. Okay? Did I say that right? This is your u, this is your dv, right? Or this e to the negative st is your u, and f prime of t dt would be your dv. Okay? If you do the first, u equal f prime of t, you're going to get du equals f double prime of t and all this stuff. And you're going to end up having to integrate, if you just think it through, f double prime of t e to the negative st. Whereas if you do this one, u equal e to the negative st, there's your du. Your dv is going to be f prime of t dt. So what's your v? Well, everybody saw that. Very good. Antiderivative of f prime of t is f of t. And that leads you to this. Very straightforward. There's your u, v, e to the negative st, f of t. Evaluated between 0 and infinity. And of course, at 0, you're going to get a 1 here. At infinity, this is going to approach 0. Okay? So you're just going to get the f of 0 at the lower limit. That looks like you're going to get a negative f of 0 there. Okay? Over here, well, what you get if you just write down your v du is this, and that's just, this integral is just the Laplace transform of f of t. So it's f times the Laplace transform of s times the Laplace transform of f of t. Now, just a kind of a preview, because we're not really applying it to the first order equation exactly. I guess we sort of are. But to solve this equation, you just subtract the t squared from both sides and integrate. Okay? But just to see how we can translate this to Laplace transform space, okay? We do the Laplace transform of this. Okay, now Laplace transform is a linear operator. You understand that if I put the sum of two functions in here, in the definition of the Laplace transform, is going to break into two integrals. The first function integrated, the second function integrated. So it's very plausible and should be fairly obvious that this is going to be the Laplace transform of y prime plus the Laplace transform of t squared equals the Laplace transform of e to the 4t. Okay? Now the Laplace transform of y is negative y of 0 plus s times the Laplace transform of y. Then you add that to the Laplace transform of t squared, which is what? S squared over 2. And that equals the Laplace transform of e to the 4t, which is 1 over s minus 4, where s has to be greater than or equal to 4. Okay? So you can now solve this for the Laplace transform of y. And it's just algebra at this point, there's no calculus. Calculus has already been done, as long as we have stuff that we've already done it for. You don't have to figure out the Laplace transform of t squared more than once. And you put it in a table and say, yep, that's it. And yeah, if I forget it, I can integrate it. Okay, some of them get really tricky, heaviside functions and stuff. It's not that tricky, it's not hard to understand it. Anyhow, you can solve this for L of y. It's going to be okay, you just put all this stuff on the right-hand side, right, and divide by s. So you divide this by s, you get this. You divide the negative of s squared over 2 by s, you get s over 2. And then you're going to have plus y of 0 over s. Okay? So, now we haven't proven it, but the transforms are one-to-one, and you can do the inverse transform, okay? In other words, you just figure out, okay, what has this transform? What has this as its transform? What has this as its transform? Okay? And that's it, and you've got the solution to the differential equation. So you take the thing from a differential equation to algebra, you solve it, the Laplace transform of the function, and then you find out what function has that Laplace transform, and you've solved the equation, which is really slick. Now there's a lot of terminology and machinery that still has to be developed, and we're not going to go super deep into this, but we're going to do some stuff with it. So I want you to consider knowing this much when you come to the test. As I say, the problems will be optional, but November is going to go a lot smoother for you if you can do this, and it's not very hard. It gets harder, but get this down and it doesn't get hard. You know, it really doesn't get all that hard. I mean, yeah, eventually it does, not in this course. Okay. We just want to lay a foundation. And if you're in a field where you got to do more with it, well, you take a more advanced course. Okay?